So welcome to IQ Tuition Center online classes. So today we're going to do physical quantity. This is the first topic in physics or engineering science for level 1. So the first question is, what are physical quantities? What are physical quantities? What are physical quantities? So that's the first question here. What are physical quantities? So physical quantities are just quantities that we can measure or quantities with measurable features. Let's say these are quantities. These are quantities. Quantities with measurable features. Measurable features. These are quantities with measurable features. Okay. Measurable features. Okay. So these are just quantities with measurable features. So number 2, say, what are the two categories? What are the two categories of physical quantities? What are the two categories of the physical quantities? So we have two categories. The first one is what? This is what we call fundamental quantities. Fundamental quantities. And number 3. Okay, let's use this one. And number 2, for what we call the what? The derived quantities. And these they are also called the what? Base quantities. These are also called base quantities. Okay? The 3. Okay. What are fundamental quantities? And give 7 examples of what? Fundamental quantities. Fundamental quantities. Okay. So what are fundamental quantities? And give 7 examples of what? Fundamental quantities. What are these fundamental quantities? So let's say fundamental quantities. Fundamental quantities are simply quantities that are independent and they cannot be expressed in terms of the other. So these are independent quantities that cannot be expressed in terms of the other quantities. Independent quantities. That can not be expressed in terms of the other. Or the others. So these are independent quantities that cannot be expressed in terms of the other. What do we mean by independent quantities here? And what do I mean by expressed in terms of the other? Let's do this. What do I mean by that? Okay. For example, let's list down 7 quantities, fundamental quantities or base quantities. Let's say, number 1, we have what? Let's say, length. And this length is measured in what? In meters. In meters. So, what else are we seeing here apart from meters? There's nothing. So, meaning meters is what? Is independent. And what do I mean by being expressed expressed in terms of the other. For example, we have what? We have M, then we divide with what? With S. So meaning M is expressed in terms of what? S. So meaning they are expressed in terms of the other. So these, they cannot be expressed in terms of the other. They cannot be meters per second, meters per watt. If it is just mass, meters, it's just meters. So they cannot be expressed in terms of the other. So let's go to number 2. Number 2, what do we have? We have what? Mass. And mass is measured in what? Kg. Number 3, temperature. Temperature what? Okay. Number 4, time. And time in what? In seconds. Number 5, electric current. And electric current in what? In amps. Okay, or ampere. Number 6, amount of substance. Amount of substance. Measured in what? In moles. Okay? Number 7, luminous intensity. Luminous intensity measured in what? In candela, which is CT. Okay. So these are the 7 fundamental quantities. These are the 7 fundamental quantities. So these are the 7 quantities that cannot be expressed in terms of the other. So these, they cannot be expressed in terms of the other. So when they tell you to list down the 7 fundamental quantities, these are the quantities. But be careful in the exam, when they ask you to list down 7 fundamental units, so meaning there we're talking about what? Units. So meaning it will be meters, kg, Kelvin, seconds, amps, mole, and what? And CD. These are the units. These are the fundamental quantities. These are the fundamental units there. Okay. So solve question number 3. Let's go to question number 4. Okay, question number 4 here. So, what are derived quantities? Quantities. What are derived quantities? And list down at least 3 derived quantities. What are derived quantities? And list down at least 3 derived quantities. So what are these derived quantities? So these derived quantities, they come from what? From fundamental quantities or the basic quantities. So these, they are obtained by multiplying or dividing 2 or more of what? Fundamental quantities. So, for example, when we divide meters, meters divided by seconds, so meaning we make what? Meters per second. Okay. So these derived quantities are quantities obtained by multiplying or dividing 2 or more of these fundamental quantities. Okay. So these are quantities. Okay, say these are quantities. Obtained by multiplying and dividing 2 or more what? Or more fundamental quantities. Quantities or base quantities. So these are obtained by multiplying or dividing 2 or more what? Or fundamental quantities. Okay? So these are obtained by multiplying or dividing 2 or more what? Fundamental quantities. So these are obtained by multiplying. Okay? So let's go to the next part here. Let's do the next question here. So when we do topics in this manner, in question form, we'll be moving faster. So I've started from the first topic here, and we'll finish all the engineering science topics within a week. So that's how we can go to mathematics and these other courses. Okay. And list down at least 3 examples. Okay. So let's say example 1 here. Okay. Let's say, because we are saying these are obtained by dividing or multiplying 2 or more fundamental quantities. Let's try to divide meters and and seconds. So when we divide meters and seconds, we make velocity. So meaning we have divided 2 of the fundamental quantities and we have made this one, which is velocity. So meaning velocity is It's a derived quantity. Okay, let's go to number 2. Meters per second squared. So meaning here it involves dividing 2 fundamental quantities. So meaning what is the answer here? Is acceleration. Okay? What else? Let's say pressure or force. Okay? Force. And you know that force goes to mass times acceleration. So meaning what are they used for mass? kg. What are they used for acceleration? Meters per second squared. So meaning here there's multiplication or dividing of 2 or more fundamental quantities. So meaning force is It's a derived quantity. Okay? Number 4, let's go to pressure. What is pressure? Pressure is equal to force over over area. What are the units for force? These kg squared divided by what are the meters? What are the units for area? It is meter squared. So here there's dividing or multiplying of 2 or more fundamental quantities, meaning pressure is Pressure is a derived quantity. Okay? So there are a lot. As long as they involve multiplying or dividing of 2 or more of these quantities there. So meaning they are They are derived quantities. Okay? So there are a lot of density. They go on and go on. Now what moment? All those they are They derived quantities. Okay. Okay. So what is the next question here? What's the next question can they ask us here on this first topic here? What is the next question they can ask us on this topic? And I guess there's no other question they can ask us on this topic. So let's go now, let's move to what we call dimension analysis. Let's go to what dimension analysis. So answer the question forward. So the first question is what is dimension analysis? So what is this dimension analysis? Dimension analysis is just the start. The start of the relationships between physical quantities. And units. So, dimension analysis is just the study of the relationship between physical quantities with the help of dimensions and units. Okay? So, number 2, explain the 2 principles. Explain the 2 principles of dimension analysis. Principles of dimension analysis. Okay. So explain 2 principles of dimension analysis. What is the first principle? So the first principle here of what? The principle of homogeneity. The principle of what? Of homogeneity. homogeneity. Okay? So what is this principle of homogeneity? So this principle of homogeneity states that the dimensions stroke the units on the right hand side of the equation, should be equal to dimensions or units on the left hand side. So the principle of homogeneity states that the dimensions of the units on the right hand side of the equation should be equal to dimensions or units on the other hand side of the equation. So for example, if we here have meters per second, so meaning even this side of what? Meters per second. So this is the meaning of this. This one is strictly if you have meters per second here, even this side of what? Meters per second. What is this? The next principle. So the second one is what? The principle of what? The principle of So what does this principle state say? So what does this principle of heterogeneity state? So what does this principle of heterogeneity state? So this one states that the units stroke dimensions on the right hand side of the equation are not equal to those on the other hand side. So this one is just the opposite of this. So this one states that the dimensions of the units on the right hand side of the equation should be equal to the dimensions of the units on the left hand side. So but this one just says that this is the principle of, and here this word homo means same. Okay? This word homo means same, and this heteros up to here, this one means what? Different. So meaning the units of the dimensions on the left hand side of the equations are not equal to the units of the dimension on the what? On the left hand side or on the other hand side here. So these are the two principles we need to understand on dimension analysis before we solve any question. So these are the two principles we need to understand. Okay. So let's talk about the uses of this same dimension analysis side. So this 3. This down. At least 2 uses of what? Dimension analysis. So list down at least 2 uses of what? Dimension analysis. So what's the first thing here? So dimension analysis will help us reduce the combination of units into their simplest form. So to help us reduce the combination of units into their simplest form. So dimension analysis will help us reduce the combination of units into their simplest form, okay? Number 2. So dimension analysis will help us check the equations. Check the equations. Equations and which is 3. Establish the quantities. Establish the quantities with what? With dimensionless constants. Okay? So this dimension analysis here will help us reduce the combination of units into their simplest form. It also help us check, okay? Let me complete this one, it's not complete. Help us check the equation. Check the equation. And establish the quantities with the dimensionless constants. Okay? Dimensionless constants. Okay. So it will help us establish the quantities with the dimensionless constants. What do we mean with dimensionless constants? We are talking about those without units. So these are the uses or the advantages of what? This same dimension analysis here. So let's move forward. So clues to follow when we are doing dimension analysis or when you answer the question here. So clues to follow here when you are doing the dimension analysis. So the first one, always, okay, say ignore the what? Ignore the constant. Constant. What do I mean by the constant here? So we mean n number, n trigonometric function, comma, exponentials, of pi. Okay. So meaning you need to ignore n number, trigonometric function, exponentials of pi. Okay. So we need to ignore them that they are not there in the equation. So number 2. Okay. Horace. Solve the right hand side and the what? And the left hand side separately. Okay. So always solve the right hand side and the left hand side what? Separately. So we need to solve the left hand side of the equation alone and the right hand side of the equation what? Alone. So that will help you make your work neat. Okay. Number 3, let's say conclude whether the equation is dimensionally correct or what? Or not. Okay, so just using these 3 laws here, we can answer any question of dimension analysis. We can answer any question of dimension analysis here. We can answer any question of dimension analysis. Okay? We can answer any question of dimension analysis here. Okay. And here on dimension analysis, there are what we call dimensional units and dimensional letters. So dimensional letters are these one. T, which is equal T representing time in what? In second. Then we have M representing mass in what? In kg. Then we have L representing what? Length in meters. So these are dimensional letters and these are dimensional what? Units. These are dimensional letters and these are dimensional what? Units. So you should be careful in the exam. When they say, sometimes they say verify the dimensional correctness of this following equation, meaning we are using these dimensions here. When they say dimensional units, we use the units there. Okay? So now let's answer a question. Let's answer a question. So from question 3, let's go to question 4. Let me put it here. Let's go to question 4 here. Question 4. Question 4. Verify the dimensional correctness of the following equations. Okay, of the following equations. Of the following equations. Verify the dimensional correctness of the following equations. So let's say the first one, V is equal to U plus what? Plus 80. Second one, V squared equals to what? U squared plus what? 2AS. Okay. The third one, let's say V is equal to the square root of what? 2GH. Okay. What's the next one? Let's say T, which is the period, equals to 2 pi square root displacement over what? Displacement over acceleration. Over acceleration. Displacement over acceleration. Which other one can we put? Which one can we put? Okay. Let's start with these 3 questions here. Let's start with these 3 questions here. Okay. And when we are dealing with dimension analysis, it's not always that you have the left hand side equal to the what? The right hand side. So we have 2 principles. The principle of homogeneity, which says that the units on the left hand side should be equal to the units on the right hand side, and the principle of heterogeneity, which says it's okay to have different units on this side and this side. So it's okay. So it's not always that you will find that they are equal to each other. You don't need to force things. If you find that they are not equal to each other, you don't need to force things. Don't force things to make them equal to each other. You have 2 principles, it's still okay, even if they are not equal to each other. But just need to conclude, say, therefore, dimensionality not correct. So let's solve question 1 there. Let's solve the first one. The first one here is what? V is equal to what? U plus what? Plus 80. Okay? Plus 80. Let's say this is the what? Left hand side. And here I'll put the what? The right hand side. Or the equation. So which one is the left hand side of the equation? This one before the equal sign, and this one is the what? So the right hand side, and this one is the left hand side. So say V. What are the units for V? For velocity, which is meters per second. And what are the dimensions? So say V is equal to what is M? M is represented by letter L. And what is S? S is represented by letter what? By letter T. Okay? So let's go to the right hand side where we have U plus what? 80. Okay? What are the units for initial velocity? This is meters per second. Plus what are the units for accelerations? Meters per second what? Squared. Multiplied by what are the units for time? These seconds here. Okay? So we have solved this hand side, we have found these dimensions. So let's also solve this other hand side. So meters is L, S is T, plus what is meters is L, S is T squared. So it will be T squared multiplied by what? By T. Okay? So from here you can see that this T and 1 T here will cancel. So meaning we remember L over T plus what? L over T, because we only made one T here, okay? Then from here, L over T plus L over T. So this just same as when you have X plus what T plus X. These, they are the same. What's the answer? It's 2X. So even here, these are the same, so just put 2, then L over what T? Over T. So L over T here, okay? And again, what is this 2 here? So I said ignore the constant. Any number, any trigonometric function, any exponential. So we need to ignore what? The constant. So when you ignore the constant here, so ignore the constant. Ignore the constant. So when you ignore the constant, so meaning the final answer will be L over T. So I've seen that the dimensions on the left hand side are equal to the dimensions of the on the right hand side. So therefore you need to conclude say, therefore dimensional what? Correct. Therefore dimensional correct. So therefore dimensional correct. So we have answered this one. Let's go to the next question then. Let's go to the next question. So the next question is V squared is equal to what? U squared plus C 2 what? AS. So again you do the same, say left hand side and you put what? Right hand side here. Okay? So what is the left hand side of V squared? What are the units for speed? This is meters per what? Per second. But here this velocity squared, so you can square this one and square this one out. So V squared is equal to, this is L squared over what? Over T squared, because L is representing length in meters and T is representing time in seconds. Okay? So let's solve this other answer here to be U squared plus 2AS. Okay? So what are the units for initial speed of meters per second? And these are square, multiplied by 2. What are the units for acceleration? This will be meters per second squared multiplied by what is S? So in this, S represents what? Displacement. And displacement is measured in what? Meters. So multiplied by what? By meters. Okay? Then from here, this is L squared over what? Over T squared multiplied by, if you want you can ignore the constant. Let's ignore the constant from here. We will remain with what? M multiplied by M to what? M squared over what? Over S squared. Okay? So here to L squared over what? Over T squared multiplied by, this is L squared over what? Over T squared. So you can see that these are the same now. These are the same. These are the same. So the answer here will be what? 2 L squared over what? Over T squared. So from here what do? You can ignore the constant. So when you ignore the constant, we ignore this number. Ignore the constant. Ignore the constant. So meaning the final answer will be L squared over what? Over T squared. So here I've seen that this left hand side is exactly the same as the what? As the right hand side. So we can say therefore dimensional what? Correct. Dimensional correct. Okay? So let's go to the next question there. Let's go to the next question. Let's go to the next question. So the next question there is, so this is left hand side. And here we put what? Right hand side. Okay? This is V representing velocity in meters per second. It's meters per second or meters over second. So what are the dimensions for V? This is L over what? Over T. So you go to this other hand side, you have the square root of 2GH. So this just same as what? 2 multiplied by what is A? What is G? This is acceleration due to gravity, which is meters per second squared multiplied by what is H? This is height measured in meters. Okay? And from here, say So let's ignore the constant from here. Ignore the constant. Let's ignore the constant. So inside you have what? This time this one will have what? M squared over what? S squared. So this just same as what? M represented by letter L squared over what? Over T squared. So meaning this is just the same as square root of L squared over square root of what? T squared. So meaning this is equals to L over what? Over T. L over T. So meaning the left hand side is equal to the right hand side. Let me conclude. Therefore, the equation is dimensional what? Correct. It's dimensional correct. Okay. So let's go to the next question. Let's go to the next question here. The next question. T equals to 2 pi square root of displacement of acceleration. So the same thing here, see? Left hand side, which is T, and what is this T? So this T represents period, which is measured in seconds. Okay? Is measured in seconds. So this side, say right hand side, goes to what? 2 pi square root of displacement of acceleration. Acceleration. So this 2 pi here, is the constant. The constant, so we need to ignore the constant. So we ignore the constant here, meaning we remain with what? The square root of. And what is displacement? So displacement is measured in meters, let's say, okay? And what is acceleration? This is meters per second squared, okay? This just m multiplied by, this one can go up and this one can go down. If you want to multiply them, s squared over what? Over m, okay? So from here, this m and this m can cancel, then remain with what? S squared, okay? Meaning here, what is the square root of s squared? The square root of s squared is equals to what? S. So meaning s is equals to s, then you can say, therefore, the equation is dimensional correct.